Dear learners, welcome to my YouTube channel. Today we will be discussing one of the important topic, that is some types of special diodes in electron devices. Okay, let's start today's lecture. So first we will discuss about the PNPN diode. Okay, you might be wondering what is PNPN diode, or maybe I write it in a wrong way. Well, we'll try to understand this. So all of you have already know about PN junction diode, which is very common to all the semiconductor learners. We will try to understand what is PNPN diode and their corresponding construction of that, and the working principle of PNPN diode. Okay, let's see. So the PNPN diode is basically, so here the PNPN is a four-layer device, as the name suggests, PNPN. So this is a four-layer device and also known as Shockley diode. Please don't be confused with Schottky. Okay, that is different, right? Here this is called the Shockley diode, as after the name of its inventor. Okay, so the function of this diode is similar to a normal diode, exclusive of any trigger inputs. Okay, so this is important. So similar to the normal diode, exclusive of any trigger input. Okay, please remember this point. Okay, so these diodes include simply two conditions, like either on or off. So these diodes are classified as thyristor. Okay, so they can be either on and they can be either off. Okay, so these are a special type of classification which we call it a thyristor. Okay, we will see next its construction and how this works. Okay, so as you can see in the image, this is junction 1. So if it is junction 1, this is junction 2, and this is junction 3. Okay, because the anode is starting from this here, P side, and the cathode is at the N side, but in between also there are another N and P, as you can see in the image. Okay, so it is formed by sandwiching four layers. Okay, 1, 2, 3, 4, right? So this is consisting of four layers, namely the p-type, n-type, p-type, n-type, respectively. Okay, and here you can see the circuit symbol of this kind. That okay. So as there are four layers, definitely there will be three junctions. One, two, three. These three junctions will be there due to the merging of four layers. Obvious. This is very obvious, right? When this diode is operated in forward bias, then both the junctions like J1 and J3 are forward bias, whereas J2 junction is reverse biased. Okay, so we will try to understand. When the diode is operated in forward bias condition, both the junctions J1 and J3, this is J1 because this side we are connecting positive side, so obviously this will act as the forward bias, and this side we are connecting as the negative of the battery, then this N type, and it will become the junction as the forward bias, and this in between this junction will become the reverse bias. Okay, how this happens? So the construction of Shockley diode can also be understood by two transistor model. How? We'll try to understand this now. Two transistor model. So this is very important. Two transistor model, right? So if we consider the anode is, this is Here you can check here, right? This is PNP and this is NPN, the two opposite type of transistor, or basically BJT, bipolar junction transistor. And here how it is similar, we'll try to understand. The emitter base junction of transistor T1, emitter base junction of T1 is the junction J1, and the common connected base and collector of transistor T1 and T2 respectively constitute junction 2. Okay, so the commonly connected base and collector of the transistor T1 and T2 respectively constitute junction 2. So this makes junction 1, this makes junction 1, and this portion makes junction 2, and this is junction, and the base emitter junction of T2 is junction J3. Okay, so it will be more clear from the circuit signal. So this is transistor T1. Okay, so the emitter base this junction. Okay, so this is J1, right? And the common connected base and the and collector of T1, this junction and this junction collectively makes J2. Okay, and this junction is J3. Okay, this is how the two transistor model and its equivalent circuit, and we can easily understand the functioning of this PNPN diode. Okay. When the anode of junction J1 J3 is made positive and cathode as negative, the current starts increasing gradually. Okay, this is very common practice for the case of any kind of PN junction. But before attaining breakover voltage, the resistance offered by the diode is quite high. Okay, this point is important. Okay, first line is very general, but this is important that before attaining the breakover voltage, the resistance offered by the diode is quite high. Okay, small amount of leakage current flows through the diode. Okay, a small amount of leakage current only flows through the diode because at the at that condition the resistance offered by the diode is very high. Okay, as you can see in the image, the leakage current. This is the leakage current. Okay, this diode includes two operating conditions: conducting and non-conducting. Obviously, either it will conduct or it will not conduct. Conducting means it will be on condition, non-conducting means it is off condition. Okay, so in a non-conducting state, this diode works on a lower line through negligible current, and a voltage is less than breakover voltage or switching voltage. So what is breakover voltage? Here at this point you can see this is the breakover voltage. Okay, and this point is breakover voltage. Okay, so these are the explanation of the characteristics of PNPN diode. Okay, now we will try to understand the Shockley diode equation. Okay, it may be well known to all, but still we will just try to have our doubts cleared about this. The question, the equation of the Shockley diode shows the relationship between the diode current and the applied voltage in both forward and reverse bias. Okay, so this diode actually applicable for both the forward bias condition and for the reverse bias condition, because if you see, this VD is the applied voltage across the diode, whereas this IS is the reverse saturation current. Okay, and this current is the forward or the reverse current. Okay, so this is basically the diode current. IS stands for the reverse bias saturation current, and VD stands for the applied voltage across the Shockley diode. So this diode equation is very much well known, but most of the cases this minus one term is negligible. So finally we are very much happy to write the equation like I is equal to IS, and then exponential of Vd divided by eta kt, right, eta kt. So this will be the final equation, because we can neglect one, because this is very greater than one. Okay, so this is how we can simplify this chocolate diode equation. Okay, so this is all about the understanding of the PNPN diode, right? So what we learn about this, the construction of PNPN diode, and thereon we also try to understand the diode with the two transistor model. From the transistor equation and the circuit diagram, we tried to understand the equivalence of the three different junctions of the PNPN diode and how they can behave at different conditions like breakover voltage and other things. So those things also we understood from the VI characteristics of the PNPN diode, and finally we saw that this is also a useful device. Okay, so what could be the question from this portion? Okay, so it might be asked that describe the PNPN diode with construction and working principle. Construction means here you have to draw the physical structure, and then you have to say the function like when the anode is positive, cathode is negative, which junctions are in the forward bias and which junctions are in the reverse bias mode. So all this explanation and the working principle, how it works and how the current is flowing. So you have to explain all these things. And again the IV characteristics, which is the current voltage characteristics, you have to explain, and maybe you will be asked for some application of these things. So this could be the possible questions from this portion. Right. Now we will try to understand a different topic, which is TRIAC and DIAC. Okay. So these devices are also important to know some basic principles in the device domain. So here we will also see what is TRIAC and their construction and characteristics, and the similar thing for DIAC also. Okay, let's start. So as you can see, TRIAC TRIAC is a three-terminal bidirectional. Okay, so there are a couple of important terminologies. Three-terminal bidirectional semiconductor device. So these are the two properties of the device, and of course this will be a semiconductor device, right? So this TRIAC stands for triode for alternating current. Triode, triode for alternating current, right? Triode for alternating current. So triode, you may not be that much habituated with this term. So basically you can think of triode as the vacuum tube version of the transistor. Okay. So the name came from the similarity or analogy of the diode, and then the name comes as triode. Okay, so there will also be a three terminal, so that's why it becomes triode. While the diode was two terminal and the triode is three terminal, but it was initially invented during the vacuum tube times where the semiconductors were not that much popular and we could not find the action of these things. Okay, that time triode used to be a popular device. Okay, so now it conducts current in both directions. Okay, so this is important that it conducts current in both directions and gate terminal controls. Okay, so the gate terminal, the third one, controls and the current can flow in both the direction like this way or this way. Both the directions it can flow. While this one will control, this one will control the flow of current. Okay, now we'll see the construction of this track. Okay, so here also track may be looking like similar like four layer device like PNPN. So this is also a four layer device, six dope region and three terminal device. Well, for the physical parameter you need to understand this four layer but the six dope region. Okay, you may be thinking that four layers would give us four dope region, but if you see the structure, there is a different dope region inside this P1, and there is two different regions inside this P2. So that makes us three different doping region or doped region, while the layers are only four, right? On the three terminal device, because you can see this is one terminal and one terminal and one terminal. So basically these two terminals are like anode 1, anode 2, and this is the gate for the controlling of the voltages. Okay, so here it is written also the gate terminal is connected to both N3. Gate terminal is connected both N3 and P2, P2, both N3 and P2, so that this gate triggers the device when both positive and negative voltage is applied. Okay, so why this gate is connected to both? Because it will enable the gate to trigger the device when both the positive and the negative voltage is applied. So that is why it is connected to the both type of dope regions, right? Now we will see the characteristics of track. Okay, as we can see from this image, we will try to understand these parts. Okay, so a triac blocks current in both directions with only a small leakage current. Okay, now here it is saying that the triac blocks current in both directions, right? While only passing a small leakage current. Okay, when the MT2 voltage exceeds, okay, MT2 voltage exceeds the breakover voltage, okay, exceeds the breakover voltage, it starts conducting. Okay, this is region, you can see this is the on state region, it starts conducting. Okay, the gate voltage controls the current flow through the track. Okay, so this is what we need to understand. The gate voltage controls the current flow through the track. Okay, through the that total device. Okay, when the device starts conducting. Okay, now when the device starts conducting, a large current flows through it. Obviously, when it starts conducting, means it is acting as a open switch. Okay. So this high inrush current should be limited by an external resistor to prevent the damage. Okay, so as soon as the device starts conducting, the current flow will be very heavy, and for this sudden amount of high current, the device may be damaged, basically it may be burned. So we have to connect a resistor to prevent that much of current flowing through the device, so that the resistor will absorb some portion and the device will be saved from being burned out. Okay, so this is what we can understand from the characteristics. Now we will see some advantages and disadvantages of TRIAC. Okay, so first we will see what are the advantages. Okay, so first we will see the advantages. So this TRIAC needs single fuse for protection. So this is one advantage, that it needs single fuse. Okay, the next one is it can be triggered either with positive or negative voltage. So you don't need to be very much specific that we need positive only or we need negative only. So it can be triggered by both of them, either positive or negative. Okay. It has safe breakdown in either direction. Okay. So sometimes we notice that there is breakdown for the forward and the backward, both sides, but it is different. Okay, but here the benefit is that breakdown is safe in both the directions. Okay, again it turns off when the voltage is zero. Okay, this is also one benefit, that if the voltage is zero, it will be turned off automatically, right? So these are the few advantages of TRIAC. Now we will see some disadvantages of TRIAC. So TRIAC is not suitable for DC application. Okay, so this one is not applicable for DC application. All the benefits so far we noticed, but these are for AC operation. Okay, and another disadvantage of TRIAC is that since it is triggered at either direction, triggering circuits should be configured carefully. Okay, so the triggering circuit is generally very much specific, but here anyway it can trigger. So you have to choose the parameter of the triggering circuit, basically the components of the triggering circuit, very carefully, so that it will be useful for using this track triggering. Okay, so these are the advantages and some disadvantages of track. Now we will see the application of track. Okay, so it is used in high power lamp switching. Okay, so all these things are basically for high power. This DAC, track, all these are basically useful for the high power applications. Another case is used to control the AC power, that is also comes under the high power condition. Okay, it is used in the light dimmer, used to control the speed of electric fan and small motors. See, this is on important domestic applications where track is used also. So these are the few applications of track. Now we will see what is DIAC and their operation and all these things. Okay. So DIAC stands for diode for alternating current. Similarly, the TRIAC was, the abbreviation was TRIAC, but it was standing for triode for alternating current, where this DIAC stands for diode for alternating current. And here we will see that it is a bidirectional semiconductor switch. Bidirectional switch. So the switch could be one directional, but here it is bidirectional. That can be turned on in both the forward and backward direction. This looks very similar like track, right? So it starts conduction when the applied voltage increases, okay, above the breakover voltage VBO. Above the breakover voltage VBO, when the applied voltage goes beyond this VBO, the diode starts the conduction. Okay, this is very much similar like the other applications, these relevant applications, this kind of devices. Okay. Now we will see the construction of diode. Okay, so we can think of the comparison between TRIAC and DIAC. As you remember that for the case of TRIAC, it was 6 regions, 4 layers, 6 regions, and the gate control was connected to both the N-type region and P-type region. But here is the difference that you see, this is one region, this is region 2, this is region 3, this is 4, and this is 5. So one region was less. Actually, this side there was a region for the case of track. Okay, but it is missing here because this is the two terminal device. We don't need the third terminal. Okay, let's see what is the explanation of these devices. Okay, so the DIAC is made up of 5 layers and two terminals. Obviously, we have just noticed this thing. It has two p-type layer and three n-type layers. It has no base or gate terminal. So these things we already discussed about the actual structure of the DIAC. Okay, although the diode looks similar to a bipolar transistor, its middle layer is not connected to any terminal. Okay, so it may look similar like emitter base collector configuration of the PNP or NPN BJT, but the middle one is not connected anywhere. There the middle one was base and it actually controls the collector current. So the difference here is that the middle one is not connected to any terminal. Okay. At the breakover point, the device starts conducting, showing negative resistance where current rises and voltage falls. This is very interesting. Negative resistance region. We have noticed this kind of phenomena during our discussion of tunnel diode. So this resistance, negative resistance region stands for the increment of current with the decrement of or fall of voltages. This is like opposite. Okay. So the characteristic says during the positive half cycle, MT1 is positive with respect to MT2, whereas MT2 is positive with respect to MT1 in the negative half cycle. So basically for the positive half cycle, this MT1 is positive with MT2, and for the negative cycle, MT2 is positive with MT1. Okay, you can see all these things from this curve. Okay, so this is the leakage current amount. This is the forward conduction region, reverse conduction region, and we can see the negative condition. Okay, the current is increasing, but instead of going this direction, it is going this direction. That means the voltage is dropping. So this is why it is called the negative region. Okay, negative resistance region. When the voltage is below the breakover voltage, only a small leakage current flows through the below the breakover voltage. Only a small current flows through the device and it stays in the off state. So because the small current is flowing, we are not considering this current to be significant, and that's why we are considering this condition as the off state. Okay. So what are the advantages of diode? There are lots of advantages actually, but we will just mention few of them. The first one would be the smooth control of power and current is achieved using diodes. Okay. The device can be turned on or off by decreasing the voltage level. Okay, so and their switching actions could be controlled by the voltage level. Okay, so this is the second advantage. The third one is reliable for low power application. Okay, earlier we noticed that the TRIAC is useful for the high power application. Now we can see that it is the DIAC is reliable for low power application as well. Okay, so now we will see some disadvantages. The most important one is that DIAC is that it needs a minimum of 30 volt to conduct. Minimum of 30 volt, which is not a small number for the case of low power application. So this is one kind of disadvantage of this DIAC application. Now we will see what are the different applications of DIAC. So diode for alternating current is mainly used in lamp dimmer circuit. Okay, it is also used in heat control circuit. It is used in triggering device for track. Speed of universal motor can be controlled using this. So the applications are more or like in the similar domain as like the track. Okay, now we can quickly compare track and DIAC. So obviously the track is, the name is different, triode for alternating current, and for the DIAC it is diode for alternating current. And the track is three terminal device, DIAC is two terminal device. The track controlled bidirectional switch, it is uncontrolled bidirectional switch. It is triggered by applying either positive or the negative voltage pulse. It is triggered by increasing the voltage above the breakbar, which is 30 volt. Also, this is a disadvantage. It has a separate control unit used for triggering the track. It does not have any control unit. Okay, so these are the basic DAC and track difference. Okay, so what we understand from this video, that the construction and characteristic of track and DAC both, and how DAC conducts current for both the directions. Okay, so what could be the questions? Definitely it will be asking for the illustration of diode, DAC or DAC application areas with respect to their corresponding working principle and their physical structure. So this could be the questions for this region. And what is DIAC, what is track? These are the common questions you could be asked for in the exam. Okay. Okay. Thank you for watching this video. We will see you in the next video.